In this next lesson, we're going to be focusing on transformations. Recall from last year in pre-algebra, we talked about geometric transformations, which is when we took a shape and moved it around the coordinate plane. Last year, we learned about geometric translations, which was just taking the shape, moving it left and right, up and down. This is something that we can do with functions as well. In the video, we are going to be graphing vertical and horizontal translations, determining how to compare the original function to the new function, and figuring out how we can simplify functions algebraically. First, we are going to graph the parent function f of x equals x on the coordinate plane. The parent function is the original function. F of x equals x is the same as just y equals x. So our y-intercept is 0. Our slope is the coefficient in front of x, which is 1. Starting at 0 on the y-axis, we move up 1 and to the right 1 to create our line. Now let's graph a similar function, g of x equals x minus 3. Starting at negative 3 on our y-axis, our slope is 1, so we move up 1 and to the right 1. What do you notice about this new line, and how is it the same as f of x, and how is it different from f of x? You should notice that these lines have the same slope and different y-intercepts. Using vocabulary from the last unit, we know that these lines are parallel lines. Now graph the function h of x equals x plus 5. Starting at 5 on the y-axis, we move up 1 and to the right 1 to create our line. What do you notice about this new line? How does it compare to the original function? This line is also parallel to our original function. We can rewrite these equations g of x and h of x in terms of f of x, emphasizing that they are transformations of this original or parent function. If you recall from the geometric transformations unit in pre-algebra, when we translate a shape, say 4 units to the right, we move every point of that shape 4 units in that direction. So when we translate a function, we move every point of the function all in the same direction. These new functions, or child functions, are just like the original, or parent functions, except that we have shifted them up or down. G of x is the same function with each point shifted down 3 spaces. Shifting down 3 spaces is taking the y values and subtracting 3. So we can rewrite this as g of x equals f of x, that same function, minus 3. H of x is the same function with each point shifted up 5 spaces. Shifting up 5 spaces is like taking the y values and adding 5. So we can rewrite this as h of x equals our same function, f of x, plus 5, that we're adding 5 to all of those y units. Remember that h of x is the same as just y, so we're saying y equals f of x plus 5. Write an equation of a function k of x that is f of x shifted up 32 units. If we shift it up, that means we're going to add 32 to all the y values. So your function should be k of x equals f of x plus 32. On the new coordinate plane, graph the parent function f of x equals negative 2x plus 3. Remember, this is just like y equals negative 2x plus 3. Start at 0, 3 on the y-axis and move with the slope. Since it's negative 2, we move down 2 and to the right 1, or to go in the other direction, we move up 2 and to the left 1. Graph the function that is shifted up 5 units. This is going to be the same function, f of x, and shifting up 5 units means that we need to add 5 to every y value. So it's going to be f of x plus 5. We can also simplify this function and rewrite the equation of the line for g of x by substituting what f of x is equal to. So we start off with g of x equals f of x plus 5. But we know that f of x is the same as negative 2x plus 3, since they're equal to each other. So we can substitute that in for f of x. And then we just combine like terms. So we get g of x is equal to negative 2x plus 8. This is the same line that we would get if we were to graph g of x equals f of x plus 5. We graph that by moving each point of the parent function up 5 spaces when we're graphing g of x equals f of x plus 5. we can graph g of x equals negative 2x plus 8 by starting on 0, 8 on the y-axis and moving down 2 into the right one. And you can see that here we're going to end up creating the same line. They're the same thing, just one is emphasizing the transformation of the original parent function, and the other is just a regular equation that we can graph without knowing the original parent function. Let's do the same thing for number 11 and 12. We're going to graph the function that shifted down 7 units. We're going to graph the function that shifted down 7 units. This is going to be the same function, f of x, and shifting down 7 means we need to subtract 7 from every y value. So it's going to be f of x minus 7. We can also simplify this function and rewrite the equation for h of x by substituting what f of x is equal to, just like we did before. So we start off first with h of x equals f of x minus 7, but we replace f of x with negative 2x plus 3, since they're equal to each other. And then we just combine like terms. So we end up getting h of x equals negative 2x minus 4. So regardless if we took the parent function and moved each point down 7 spaces, or if we use the simplified function h of x equals negative 2x plus 3, we're going to get the same function. We get the same line.